These notes will help you do the homework on period, frequency, and amplitude. Here are the notes, and I will put them in topics in Cabinet so that after I've filled them out, you can access them. First, a quick recap. This type of motion here, which repeats, has a scientific name, and that's periodic motion. It's when motion repeats identically or nearly identically. There's some vocabulary you need. The most important word to review for this lesson is the word cycle. A cycle is a round trip. So for this brick, we could say a cycle starts here and ends here, like that. Start, stop, like that, a round trip. For a pendulum, a cycle would start over here and end when it comes back. So it starts now and ends now. So that's a cycle, a complete round trip. Amplitude can be a little tricky because it's very natural for you to want to measure a distance from the bottom to the top of the spring's motion. But it turns out to be mathematically more convenient to define amplitude as going from the center, or where the spring would sit at rest, and I'll show that by stopping it like that, the center where the spring and the brick would hang stationary, to one end. Let's start this motion again. I'll start it by taking the brick up to here and letting go. Okay, so amplitude is a distance, and it's a distance from the center of the motion to one end of the motion. So if I took a ruler and measured the amplitude, I would measure from here to there. That's a distance, so it would be in centimeters, meters, or feet, or that sort of thing. Okay, for the pendulum, amplitude, I marked it with the stopwatch and the ruler here as you measure the distance between these 2 points. So amplitude is from the center of the motion, which is here, to one end of the motion, which is there. And if you measured this arc, it's actually curved here with a ruler, that would be the amplitude. That will help you on the homework. All right, here is a word that's new for these notes, period. Now, you watch this motion here back and forth and you realize, oh, I could time that. I could time one cycle. And that measurement has a name. That's period, the time for one cycle. There's a symbol for it. Since it's a time, the standard symbol is a T, but it's a capital T only, never a lowercase t. We use lowercase t for any kind of time in general, or total time, but capital T specifically means period, the time for one cycle. So I'll show you how you would measure that here. We would start now. Whoops, we're going to have to do this again. Okay, so we would start now and end now. One complete cycle. We timed it and we got about 2 seconds. For the spring and the brick, same idea. We can pick any point in the motion. Pick the top, pick the bottom. We could pick the middle and have it go through like start, stop, like that. But we'll pick the bottom. That's the easiest. And when you do this for real, it's even a good idea to let the brick just barely touch the stopwatch or come really, really close. Then you tend to get an accurate measurement. So start, stop, 1.14 seconds. Right? Now, notice what the unit was for that. It had to be seconds because it's a time. So the unit is seconds. And to calculate it, this is the kind of problem you would have on the homework or a test. A pendulum takes 12 seconds to swing through 6 cycles. Calculate its period. All right, so you do that on your own. This is easy enough to do in your head, and then you can pause the video if you need to. So total time of 12 seconds, and through 6 cycles, and we want the amount of time it would take for one cycle. We've been doing this sort of thing all year, so I'm not going into a lengthy explanation, but it should be clear that if it's 12 seconds for 6 cycles, it would be 2 seconds per one cycle. Now, some people write 2 seconds per cycle. There's nothing wrong with that. 2 seconds per cycle, completely correct. I would mark it correct, but it's more common to just say the period is 2 seconds, and we all understand that means 2 seconds for one cycle. So look at what we just did. In general, if you have the time and the number of cycles, you do a division, and this came up in the homework. Oh, and in the lab. If you have the total time and the number of cycles, you just do a division like this to get the period, which is the time for one cycle. All right, so period gives you the amount of time for one cycle. The reverse of that, or reciprocal of that, the opposite idea of that, is called frequency. Frequency is more like describing the quickness, how quickly something occurs. And we encounter the idea of frequency all the time in our lives. For example, your heartbeat has a certain frequency. Radio waves have a certain frequency. So this is a very common idea, probably more common than the scientific word period. You'll hear the word frequency in life more commonly than you'll hear period, referring to the time for one cycle. You'll hear about periods. For example, the period of the Earth's rotation around the sun is about 365 days, but the word period isn't used as often as the word frequency. So here's the basic idea. The number of cycles that occur in 1 second. So you time for 1 second, you count cycles. Now that could be less than one. It could be less than one. It could be only half a cycle that occurs in 1 second, and then the frequency would be 1/2. Or it could be like 5,000. That's a frequency you could have for a spinning motor, 5,000 cycles per second. All right, here's an example. Do this on your own, of course. Pause the video. These are real numbers. A hummingbird's heart could beat 200 times or 200 cycles in 10 seconds. So how many cycles, what would the frequency be? Calculate the frequency. How many cycles occur every 1 second? If it's 200 beats in 10 seconds, go ahead and try that. And of course up here we'd put 200 cycles, and down here we'd put the total amount of time, 10 seconds, because we want to know the number of cycles that occur in 1 second. And of course we get 20 cycles per second. That's how you would write that, 20 cycles per second. There's a very simple symbol for frequency. It's a lowercase f. It's very rarely a capital F, but it's really supposed to be a lowercase f. And then there's a unit for this. Cycles per second would be fine. But the unit was renamed to make it quicker to say, have a nice abbreviation, named after a German scientist who worked with electronic frequencies in the 1800s, Hertz. And the abbreviation for it is a two-letter abbreviation, a capital H and a lowercase c. All right, so we could go back to here and we could write this as 20 cycles per second, or more commonly you would say 20 hertz, like that. And if you look at a radio, you will see things like 40, maybe let me think for a minute, 110 kilohertz for AM, or 88.1 megahertz for FM. So you'll see frequency units when you look at a radio. All right, and finally, this was at the end of the lab as an optional part, the relationship between period and frequency. Here's an example. Let's say the frequency is 4 hertz. It says calculate the period. Let me shrink this down, make sure you're still, let me redo this, so make sure you're still getting it in the screencast. The relationship between period and frequency. Here's an example. The frequency is 4 hertz. Calculate the period. Now it may seem, you may think, wait a second, to find the period I need a time and a number of cycles. And all I've got here is 4 hertz. Okay, well, frequency equals 4 hertz. 4 hertz means this, 4 cycles per second. And you may still feel like, wait, I only have one number. I only have a 4. But to do a calculation of period, I need 2 numbers. I need a number of cycles and a time. We're going to take advantage of how units work. Whenever you see a unit that's a division, like meters per second, cycles per second, the denominator means 1 second here. So this is not just one number. It's not just 4. It's 4 cycles in 1 second. That's what it means. So that means you're really being given 2 numbers. So you could calculate period. 4 hertz means 4 cycles per second, which means 4 cycles. The number of cycles is 4, and then the total time is 1 second. That's the information it's giving you. So if you want to calculate period, put 1 second on top, you do have a time, and then on the bottom, you have 4 cycles. So you could do that, calculate a period, and as a decimal, that's 0.25 seconds. So from what looks like just one number, you actually can get 2 numbers and do a period calculation. Likewise, if I gave you just a period, if I had originally said the period was just 0.25 seconds, that's really 2 numbers. That's 0.25 seconds time in 1 cycle. And you could do the calculation for frequency and you would get 4. So from their definitions of what they mean, Period is 1 over frequency, and frequency is 1 over period. And you see how that would work up here. If I gave you a frequency of 4 and I said calculate the period, you could go to this equation here. I gave you period is 4, so that would, or I say, sorry, let me go back. You go to this calculation, this equation here. If I gave you that the frequency was 4, that's giving you the F is 4, and you would put that in here, and you get that the period is 1 over 4, which is 0.25 seconds. So from their basic definitions, period equals 1 over frequency, and frequency equals 1 over period, and I put problems like this in the homework. And the mathematical term for that, which you should know, is that they're reciprocals. T is 1 over F, and F is 1 over T.